Here we are going to start a new session of Solidworks with sheet metal component design. So we just need to create a sketch over here first. I'm using some kind of shortcuts to. I just need to draw some lines over here. As you can see, it automatically mirrored the line which we need to design. Reference to the mirror line. I can define my sketch very easily. I just need to define the dimensions, and we are ready with the sketch. Now we can move forward to make it a realistic view for the sheet metal component. Let us assume like here we need to define a dimension of this 291 mm, and we can select some kind of gauge table as well. So here we have some of the gauge table. To select it, I just need to select a 16 gauge sheet. Right now everything is predefined for other stuff, so I just need to check it out. So now sheet metal component blank feature is ready. This is the basic feature which you need to start with the sheet metal component, the blank command. Here we have also designed bending as well, but right now we don't need to design some bend because in the sketch itself we have done some bending. So Solidworks is a smart software which does many of the work on that basis. Now here we are using a cut feature, a normal cut feature. Let's suppose what is the normal cut feature, we just need to know. Suppose we check it out. Yeah. So we have cutted the sheet metal component. So here we can see some of the variable radius over there at the meeting point of bend lines. So why are that? If we are using cut feature by enabling normal cut, we get those kind of variable fillets. If we don't, then we will get a straight feature. But while sheet metal operation, it is not feasible with this normal cut because it will generate this kind of errors while laser cutting the sheet metal. So we just need to use the sheet metal operation with that normal cut feature. It is a very distinguishing feature with other tools not much available in computer tools like Solidworks or others. So now we just need to design some more stuff in it. So suppose we need to design some cuts. We can design cuts as well. So we need to start with the line again. Yes, we have designed a line. Then we need to design a rectangle. So we can design a rectangle. Rectangle is just like this. And now we just need to define the dimension of this. Suppose it will be a 26. This will be like 11. Suppose this one from this would be like 40. And with this one it will be like 68. So here we have defined this line. We just need to mirror it also, so we can do mirror as well. I just need to select the entities what we need to mirror, select the mirror line, and thus it mirror itself. So we just need to cut it out those sections, and yeah, we have cut it the section. We have some more enhanced features like Hole Wizard, which are very much usable in those circumstances where we just need to use some standard stuff, like we need to do some kind of drill holes in it, and we just need to use the Hole Wizard feature. We just need to provide some dimension in it, like 4.6 and then 9.3 from here, and I just need to mirror it. So let's see how we can mirror this one. We can click this one, feature, select mirror about this line, check it out. also from here, so we can select a center line as well. We just need to select this feature, mirror about this line, and yeah, we got these 4 points to generate holes, and we have generated some holes over here. Suppose we need to generate some more holes over here as well, so we just need to do some sort of sketch, or we can do just by using hole as a feature. We just need to select what kind of drill hole we need to drill a hole of about 5.4 right now, and we just need to provide the position, and we just need to give where we need to generate the holes. First we need to generate some center lines again, and then we need to generate a point like this, and then I just need to specify the dimension in between the holes. Suppose it would be like 120, and then we just need to provide dimension from here to here. It would be like 170.57 by 2. We can even give the calculation itself in the dimension of the Solidworks. It is smart enough to calculate and provide the better results without us need to involve in the calculation. So these kind of things which reduce our time duration, time consumption in design, and we can design our part very much fast enough. So these are the very helpful feature of the SolidWorks, because SolidWorks is very smart enough. So we have generated some holes at the bottom as well. Now we just need to use some more tools, like we can design some vent. We just need to design a vent over here, because we know while designing, like this component will be heating during operation. So we just need to put our sketch over here. We just need to select the configuration, and then we need to provide a point where we need to put our sketch, and then just tick mark. And then sheet metal function, we just need to click on the vent feature. We need to provide the boundary of this. We need to select some ribs over here. It is very much easy to design a vent feature in SolidWorks. You just need to select the ribs. We need to provide some spars. We can define the dimension of ribs thickness, spar thickness as well. We need to provide some radius at these, and then we just need to do OK. And here we have generated a vent feature over here. So it is very easy to generate a vent feature. Now suppose we need to provide some kind of forming tools in the sheet metal. So we just need to select over here, select some kind of forming tool, just like louver. I just need to design over here, and then provide some details like this. We can provide the dimension as well by selecting. I just need to provide this line dimension. From here I just need to provide like 17 over here. We can provide the dimension of the point. It would be like 40. I think it is enough. And we need to coincident these 2 points as well. Make coincident. Yeah. And just check it out. It will generate a louver over here. So it is very easy to design this kind of stuff in SolidWorks, and it is very helpful while designing in sheet metal components, because we are very struggling while designing sheet metal components, because we need to think how we can design, and we need to concentrate on improving the design itself. So if we are focusing itself on how to make our thinkable tools in SolidWorks or in design software, it is very much time taking process. So SolidWorks reduce our time taking because it is very much user friendly software, and we just need to provide the details in a very simple manner. Like I just need to generate some file louvers over here with a pattern distance of 15 mm, and then I just need to check it out. It is very simple to generate this kind of stuff in SolidWorks. And then suppose I need to generate some more feature in it. Suppose right now we just need to mirror these louvers on the other side as well. So I just need to check it out. I just need to provide a plane. Yeah, this one is the plane. Features will be like linear pattern, and this we need to check it out. So I've generated louvers on the both side of the sheet metal face. There's one more other good feature, which is like a fill pattern. Fill pattern we can use fill pattern over here. Suppose creating seed as a pattern, and how much pattern we need to have over here. We can have this much amount of pattern. Suppose we need to reduce the size of the pattern, we can set the size from here. And if we need to skip some instances as well, so we can skip some instances like this. We don't need some instance over here. We also don't need some instance over here as well. I don't need this one instance as well. And at the end I also don't need this one, and this one. And after providing very much details for the pattern, it generates pattern itself on the whole side. So this kind of thing we can design in sheet metal. And one more thing, if we need to provide some sheet metal connecting to other sheet metal plate, like I need to cover that back side of the plate, so it is very easy to design itself because it is also a multi-body feature provided by the Solidworks. So I just need to select it, and you can see I'm using some sort of hand cut shortcuts. So I'm just using some kind of shortcut to generate this stuff. It will make easy, and it is very less time consuming process. So that's why I'm using it on a regular basis. And the SolidWorks is very much flexible for shortcuts as well. So I just need to make this sketch right now, and suppose I need to use some offset feature over here, making the base geometry construction, and the offset would be like 2 mm. So it is okay for me right now, and I just need to generate a base blunt feature over here because I need to cover this part from the back side, and in the reverse direction I just need to generate this flange feature. And now it is a new part developed over here in a minute only. So for joining these two parts, we have another feature in the sheet metal which is known as tab and slot. Usually, while welding, we just need to have some guidance for generating this kind of parts. So by providing this kind of feature, I just need to provide offset distance would be like 5, and we can spacing length would be like 10, and the total length of the feature would be like this. And I just need to check it out. It is showing preview of slots to me, and it seems okay to me. I just need to tick over here, and yeah, it is generated tab and slot over here. I just need to generate tab slots over here as well. I just need to select the line, face, and by enhancing previous features, I just need to check it out over here only, and it automatically generates tabs and slots here. I just need to generate some tab slots over here as well, so I just need to check it out over here. I just need to select the edge, the face, and suppose I need to generate a distance of offset value 15, total distance 30, and suppose it is required 60 or something like 30, or I just need to generate like 3 tab and slots over here. So this is how we generate some sort of feature in sheet metal within a record time, and this is very useful commands while considering the factor of manufacturing in sheet metal features. So we can see by hiding this that there are tabs are generated in the sheet metal of this component, and slots are generated in the sheet metal of this component. So it is very easy to design this kind of stuff. And suppose we just need to manufacture it, so we need to have a drawing of it. So let me save it on the desktop or somewhere else. Whatever you want to save, you can save it, and then I just need to generate a drawing for this. So it is very easy to generate drawing for this kind of component in sheet metal. I just need to select some sort of template, and then I just need to select standard view of this part. It will automatically generate some standard view of this component, and then I just need to generate some project view like this. I can generate some project view as well. Suppose I need to generate some dimension of this. I just need to select entire model, and it will generate dimension for me automatically. I don't need to invest my time for generating the dimension in the drawing feature. As you can see, it generates dimension where I need. It automatically gives some center lines. Whatever will be the dimension are here, it is automatically come to this. So suppose we don't need some center lines in this model, so we can delete it as well. So we can delete it, and we can make it 3D feature visible like this as well. And suppose if we want to generate some sort of we can say some sort of flat pattern view. So if we really want to add some sort of flat pattern view, we just need to select a view from the model. And suppose the sheet format is not suitable to us, we can change this sheet format as well. Um, Properties, while making from properties, we can select any other else as well. Suppose we need A3 size for this model, it automatically changes. And for this one, I need to generate flat pattern. I need to select a body for which I need to generate a flat pattern. Suppose I need to generate flat pattern for this body, I just need to check it out, and it will give me an option of generating a flat pattern. I just need to select it. Okay. And after checking it out, it generates flat pattern on this. It will take some sort of seconds to generate this flat pattern for this body, because it is generating automatically, so it takes time. Sometime it depends on your PC and the configuration and the heating factor of this. And we can select this kind of template, so that's why it is showing the upfront will be in green line, and in orange line it is showing that we need to bend this part in the down direction. So this kind of feature are available in Solidworks for generating the drawings and the sheet metal components. So now suppose we need to design some sort of plastic component. So let's see how plastic component are easy to design in SolidWorks. Suppose we need to check it out over here. Suppose we need to generate a line again. Here, yeah, this one. It is very easy. I just need to generate some sort of lines for this. Suppose this one, and this one. It automatically mirror the whole feature for us. I just need to provide some sort of distance, like it would be 30. It would be like 16.5. I just need to provide some sort of fillet as well. I just need to provide a fillet of 2 mm, or we can say 1.2 mm over here. That is okay for me right now. And I need to generate some sort of 5 mm fillet over here. It is okay for me. And suppose I just need to provide the rectangle with this. I will provide the rectangle of 1 degree. And then I need to suppose I just need to delete this one. We can delete this one as well, and I can define the whole sketch from here. It is okay for me, and I just need to select this one, coincident, yeah, and suppose we just need to generate a dimension from here to here. And this one is also okay for me. Suppose I just need to create offset of this about 2 mm, or we can say 0.8 mm. Yeah, right now it is sufficient for me because it generated baseline geometry. So I just need to uncheck that option that I don't need base geometry to be construction. So I just need to generate some sort of lines as well for generating a revolve feature for this. And then I just need to trim this one. After trimming this one, I can make it construction. And after making it construction, I just need to revolve this feature about the center axis. And after revolving this one, I can generate a plastic component easily. So after generating this plastic component, I just need to, then I can generate some sort of sketch, and I can offset the value up to about 2 mm or 1.2 mm, and then I can extrude it up to like 1.2 mm offset value, and with the value of 1.2 mm. This is how we can generate some sort of plastic cap over here. So this is some sort of tube of 1.5 ml. So suppose we just need to check it out, the draft analysis for this feature. We can check out the draft analysis. So it is showing that this one is the only feature which is without draft of 0 degree. Otherwise every feature is in a draft value, and showing the draft value by moving cursor on the face, it automatically shows the draft value. Suppose you need to check some sort of undercut analysis, you just need to provide a phase about which we can check it out. The direction of pull, the direction of pull is this, solid body is this, and we can check the undercut analysis. And the direction of undercut is, as you can see, there are no undercut in this figure. So it is very easy to design some sort of design like this, and now we can save it as some some of the name like 50 mm tube and text. So this is how we can design plastic component in SolidWorks. This is very simple component, and I just show you the important features of the mold design or plastic component design, where you need to check it out, the draft value, if there are some sort of undercuts or not. So this, and then I just need to generate the sketch of this, and I just need to provide dimension to this. It will be like 108, and this would be like 72, and I need to extrude it. So I will extrude it in under mid-plane value 49. So it will extrude in both directions with value of 49, and I just need to provide some sort of chamfer. So I just need to click on the chamfer option in the SolidWorks and providing the value. It will be like 1 mm to all the edges of this body. So this is how we generate a machining component. And suppose I need to generate holes related to that plastic body which I have just designed. So I just need to insert that plastic component. It is also a multi-body designing facility available in the SolidWorks, where we can select any other part as well and insert in our units in our body, and by locating that body in the feature, we just need to provide some sort of values. Suppose I just need to move upper side of the body, so we can move it to the, suppose I just need to generate it to Y. Yeah, I just move it to center of this body, and suppose I just need to generate some sort of pattern of this body. So I just need to select the direction and what will be the body of this to generate a pattern of this. It would be a testing tube, definitely. There are instances would be like 2 with a value of 30, and the direction would be like, again, would be 2 with a value of 30, or it would be like 20. we have selected the body is this one as well. So now we have generated some 4 tube pattern in the block, and I just need a 4 pattern here itself. And suppose I just need to remove the area recovering by the tube. So there is a feature which is known as indent, which we can use in it. So in the feature option, we get an indent feature over there. This one is the indent feature, the target body region, this one, and the cut one will be available for us. And suppose I will provide some target body will be like this as well, this one and this one also. So I just need to check it out. I just need to hide this body. Then by using delete body feature, I can delete this one. So I have generated some sort of 4 holes over here, and we can see these holes are very much accurate for designing purposes, because this is a medical tube which containing some sort of blood samples or DNA samples for testing purpose. So we need to have a much more accurate machining, and for accurate machining there must be accurate designing. So these are the features which are very useful for us for designing machining component on accurate level. So let's move for the assembly, how we can assemble this part, and how the assembly is going on. So let's move in the assembly. I just need to select template over here. Then I just need to provide some sort of components which we have designed right now. I just need to select the place where I just need to design an assembly. So this would be like a bottom plate. Where is the bottom plate for us? This one is the bottom plate. I just need to open it, and I'll placing this plate at some specific value, which is predefined isolated value for this component in the assembly. So it automatically fix it over there, or we can place it over here as well. So I will just check it out and place it at some specific standard space in the assembly. And after this, I just need to assemble some sort of base mount for this. So I will select a base mount here, and I just need to provide a concentric feature. As you're watching, there is some hole in it, and this would be like this hole for this. Okay, and I will provide some sort of parallel feature to this. It would be like this, and then I just need to select a coincident mate to make things happen. So this is how we can see, and we can place the components easily. We can copy the components by just providing the value um, to the features, and then it plays it automatically. We don't need to select again a feature and again place over there. I can copy that components if we have same mate value over there. So now we just need to provide some more material to the assembly and placing some other kind of base mount which is required for these holes. So I just need to place it over here by using concentric mate, and then I just need to make parallel to this face. So I just need to select this face, select parallel feature, and provide the face. As it is opposite, I just need to check it opposite, and then I need to make it possible with selecting coincidence face value. So yeah, this is available for us. I can check it out. I can copy with mates on this feature as well. So I just need to provide some neat features which we have provided for that, and we will generate this kind of assembly. So we have started the assembly by making the components and providing the value to this. And suppose we just need to make assembly, heating assembly. So we need to call a heating assembly right now. Heating assembly is this. I can place it over here, and I just need to make float to this, and I will provide some mates of this assembly respecting to this. And it is a concentric. Suppose I need to make concentric this one as well. So I'll make concentric this one. I just need coincident with this. So I have made coincident to this value as well. So now it is okay for this. Okay. Suppose we need to replace that component with some other component. So we just need to choose a replace component feature from the tree. Replace component is here, and I need to make replace with other part which we have designed. So we can select that part from the assembly. Bottom plate is this. Yeah, I need to make replace with this, and I had replaced with this component very easily because that part was the oldest one which we had designed. So this part is the newest one. So I just need to generate it. So this is some sort of possibility which we can do in SolidWorks. If we want to replace it only, we can replace it very easily. So this is the feature which is available in SolidWorks, which we can do and which reduce our time consumption process very easily. So here I just need to make it out possible. So I just need to delete this feature, control S, and then control W. Yeah, save changes, and the things are going happily. So now I just need to insert a display value. So this is the front cover assembly. I just need to select it, make it at the original position, and yes, it is at the original position. No, it is not at the original position, so I just need to make it happen. So by making it float, I need to provide a coincident value to this, and now I need to make some sort of width mate with respect to this face, this face, this face, and this face. Yeah, this is concentric. Oh, sorry, width mate with each other. Suppose I just need to cover up this assembly with lid one, so I just need to select the lid feature, lid one over here. There must be a lid, yeah, top lid over there. I can place it over here. I just need to put it that lid, and by making mate with the components, it is very easy to place that component with assembly. So I just need to make concentric with this feature. It is concentric. I just need to make reverse concentric of this one. I can make this concentric feature to this one as well. So I just need to check out the both faces and make concentric. So this is how we can place plate over here. I just need to place some more components like a rubber component over here we have designed previously. So I just need to select that component only and place it over here. So yeah, this one is the rubber component which we have designed. I just need to place it, and I just need to make some more mates to this, and by selecting this face to this face, this face to this face, it will automatically mate to each other, and then I just need to make coincident to the face of this. So I just need to select the coincident feature over here, and it make coincident. I just need to drag it over here. Look, I'm doing right or not. And then I just need to do some more width mate as well. So I just need to select these two faces, and suppose I just need to mate with this reference. So I have placed this on here, and now as for designing purposes, we have assembled this feature. Now I just need to place some sort of sockets here, so I can place some sort of sockets. I just need to select that socket. I just need to drag it over here, and then it will make easy for me to making the feature very easy. This one replicates itself, so I just need to delete this one. I just need to place it over here. Some more mates are required because it is a smart component. I'm just showing you a more facility available in Solidworks, which is a smart component facility. It is also a competitive facility, which might be some other tools are providing. I don't know. I don't know any other one is providing right now, because Solidworks itself is the tool which is providing a facility of smart component right now. So just need to check it out, the value. Yeah, we have placed the part over here automatically, and then I just need to select a face of insert smart feature, and then I just need to select that face on which we need to generate that smart feature and check OK. So let's see what happens. After hiding this, I can see there is a rectangular hole generated automatically by this smart component, and this is the facility available in SolidWorks, which you can see. So these are the facilities which we can design in SolidWorks. I have already assembled this kind of assembly. I'll come to an end when we design some sort of assembly properly and make things happen, which is very useful in assembly designing. And suppose we need to show some sort of accessories as well, we can show it from right here from a folder option. We can generate folder in the assembly itself, where we can rename it like accessories, like fasteners. Suppose we need to generate some sort of fasteners here, so it is very easy. Let me show you some more facility about this. Fasteners are available for us, so we just need to provide. It is showing a dialog box like it. I need to select the face over here. I need to add the smart fasteners feature, and as we can see, the smart fasteners are adding over here. But for now, I just need to suppose rotate this smart fastener. So we can rotate this smart fastener, but just by right clicking on it and flip it over here. So we can flip the fastener feature in it. So now we have edited the smart fasteners, and suppose we need to define the length, the type of the fastener, and a simplified or cosmetic or schematic fastener, we can add it over here. So these kind of facility are available in it. And suppose we need to add some sort of washer, so we can add washer itself over here by selecting a washer facility. Suppose I need to add a washer facility to this one as well. So yeah, we can add a washer facility. Suppose I just need to add a washer to this, and this will add a washer. We can see it add a washer to this feature, and then I just need to check it out, and it generate fastener for us without inserting some sort of fasteners manually. We can insert smart fastener feature. We can use smart fastener feature and make our assembly easy. So this is how we can design in SolidWorks. And suppose if we need to draw assembly drawing for this assembly, we can do this as well. I just need to make things happen for the assembly, and let's see how the assembly drawing is going to be happen. So this is how we have previously generated the assembly drawing for this assembly, and there are some of